Good afternoon. Come on, you do better than that. Good afternoon, everybody. All right, I like it. Do you want to go for a third time? Good afternoon. All right, I dig that. That's better. So, hey, very excited to be here with you all today. Let me start with a quick question. How many of you have ever heard about CrewAI? Raise of hands. Holy shit. All right, 1 second. Can I take a picture? Like I was in this stage a year ago, and that was no hands. So let's do this. 1 second. I want to make sure that I got this right. Don't screw this up. I just got one chance. All right. How many of you have heard about CrewAI? Damn, that's insane. All right. So I'm here to talk a little bit about CrewAI. I'm going to talk about, many of you know us by our open source framework. What it's the best framework out there. That's what I'm going to say. We also have an enterprise solution. So whenever anyone is ready to talk business, we also do that, and we love doing that. We're great at doing that. But we are shipping so much things every single day and every single week that this is also going to be a great opportunity to show you some of like the latest and the shiniest new features and how you can use them. We also have some things that we can code together. So this is supposed to be more of a workshop. So eventually, when you get to that, if you want to pull your laptop up and you want to code with us, that's okay too. If you don't want to do that, you can also do that later. All that's going to be available. Open source is going to be on GitHub. But doing live is nice. And the other thing is, once that we get to coding, I would love to get this more conversational. So if you want to ask questions, or if you have any doubts, or anything that pop up to mind, you can also just raise your hand and we can make this more of a conversation. All right. Everyone good with that? All right. Let's do it. So we like to call us the leading enterprise multi-AI agent suite. What is a mouthful? But there's a reason for every single word in here. Enterprise is because on the commercial side, we're selling into bigger companies. And the suite is because we realize that even though the framework is amazing, it's so easy to build, when you're getting to a certain scale, when you have like hundreds of agents or thousands of agents, then that starts to break. Because now it's a bunch of legacy code and you have to maintain it. And then you not only have the agents, you have the tools, you have authentication, and all the different things on top. So what we're actually building on the enterprise side, and I'm going to tell you at the tail end about it, so I don't kind of like get in your way, is like some of the things that we are building on that side as well. But on the open source, things are booming. We have developer adoption in over 150 countries. What is insane. And we have over 100,000 engineers certified on deep learning AI. A bunch of people taking these courses, and that's very exciting. If you haven't done it yet, I would say definitely do it. Also, many Fortune 500 using, we can talk about some of them eventually or off the thing. And also amazing partnerships. And that's why we have Groq with us in here. We are great partners with Groq. We're going to tell you more about Groq as well during this. One of the use cases that we will use Groq, and we're going to tell you why we're doing that. But also other partners that have been very interesting as well. 50 million. This is how many agents we run in January. I haven't pulled the numbers of February just yet. The reason why I like this number is because a lot of people are thinking about agents as something that is going to happen in the future. And I mean, yeah, 50 million is a lot, but it's going to get way higher. But what I mean is it's happening now. There's like people and companies, they're actually running these agents on a regular cadence and getting value from that. And that's very exciting. And more than the number itself is the growth. This is the actual plot of how this number has been growing in the past few months. What is insane, if you ask me. Now, many of you might know what an AI agent is, but I think it's safe to assume that some might not. So I'm going to take 2 minutes to level set very quickly. You're probably familiar with all the models, ChatGPT, Sonnet, and everything. They're great at creating content. They predict the next token. So if you ask them, hey, create an email for me, they're going to go ahead and write the email out. And you can say, make it funnier. And it's going to fail at that, but give it a try. And then you also have this thing that it's almost like a cognition feature in these models, where if instead of asking them to write an email, you give them two emails and you say, which email is better? What email should I send? This model is going to be able to choose between email 1 or 2 and say, oh, email 1 is better because X, Y, and Z, or email 2 is better because A, B, or C. And it's that ability to make those decisions and do that with a certain degree of confidence that you can explore once that you make this into agents. Because now you can step out of the room and it's not a conversation anymore. You give it a task, you give it a goal, and this agent's going to decide how to achieve that. They're going to say, all right, in order to achieve this goal, I might need to pull some data from Salesforce. So let me do that. And then pulls the data out. And then gets this data in and say like, oh, you know what? This data actually is missing some invoices. Let me pull data from SAP. And then go out and pull the data from SAP as well. So it's this ability to do this decision making that really allows you to do what in the end of the day is automations. So honestly, AI agents it's a fancy word. Everyone loves it. It's tracking. In the end of the day, we're talking about AI-powered automations. Automations that were not possible before. So things like for people that have done RPA in the past. So things that RPA promised to do and failed for whatever reason, or things that used to work but are very brittle. They break very regularly, very consistently, and you want to make sure that you can do that in a better cadence. This is kind of like a partial ecosystem feature or kind of like slide. I like to call out the fact that we work with any models out there just because sometimes some companies like to use OpenAI, other companies like to use Claude or DeepSeek or whatever it might be. A lot of more regulated companies or even engineers like to run local models. So they might run their own Gima model, for example, or they might run a fine-tuned version of Llama 3.3. And we support all of those. And we're going to show you that during this once I be getting to coding. And now I want to talk about people are building. Because you're probably curious about that. Like, all right, I get agents. I get they're cool. I get they can do automations. So what? Like, what is happening? And this is kind of like a distribution of what we're seeing in terms of use cases out there. The one thing that I love about this chart, and I'm going to give it a try. Someone like, what pops up in this chart? Anyone has any takes? Other is one thing, but the main thing is there's no clear winner. Like, it's not everyone is doing sales or everyone's doing back office. What that means is for a company like us is, well, we built an amazing use case in back office automation. Well, now it's very easy for us to do another use case on support or to do another use case on research or another use case in marketing. So you can translate all of these learnings, and that has been very interesting. The caveat here is this information is coming from a pool of 405,000 different people spread across the whole globe. So there's Americas, there's Europe, there's Asia, there's APAC in general, there's everything in here. And then the other thing is how technical these people are. Most of the people that are getting successful implementations are technical people. Now, if you ask me, long-term vision, these things will go no code. It's just kind of like a tendency in order to have more wider adoption within these companies. I think it's going to be very similar to e-commerce nowadays, where yes, there's ways that you can speed up an e-commerce in 5 minutes and it works. But if you want to do something super cool and fancy, then you're going to need an engineer. You're going to need to do your own. But today, the reality is we're not there yet. Today, even if we are doing like we're helping a company in a business unit, like a sales team or something, they are still getting more successful if they have technical people involved with it. So I think that's a good thing to call out. And in terms of how fast these companies are moving, they're moving pretty fast. One thing, again, keep the caveat that this group is a group of companies and people that came to us, so they're more progressive, right? So I think this number of almost 16% have featuring productions. If you basically go towards the broader market, it's going to be even lower because these are progressive companies coming to us to talk about AI agents. So they're already experimenting with some things for sure. And now I want to talk about use case. And then after that, we're going to talk about maybe building something and what would that be? How does that sound? Did I lose you? Are you still with me? All right. So let's do it again. Good afternoon. All right. A little lower in energy, but it's okay. We can get there. So talk about use cases, right? Some use cases that we are seeing out there. These are actually use cases in production, companies that build this. I can't tell you the companies. I can't tell you what they're doing or anything like that, but it's an interesting one. Basically, there's integration with Azure using Power Apps, SharePoint. Basically, people within those organizations can create requests using these apps. You have CrewAI pull information. This information now check internal databases for historical prices. Check external sources, things like AlphaSense to pull information out of competitors. If there's something wrong with that use case, they might ping like the person directly on Slack. Say like, hey, there's something wrong with this request that you made. And eventually, if it's approved, if there's an approval of this process, then that goes into an existing UiPath installation that broadcasts this into a series of databases internally. So, very interesting use case. I think when we initially rolled it out, this use case, it has 60% precision, what sucked. Then we spent a few weeks on it, and now it's 94% precision and 80% efficiency gains. And that's insane if you ask me, especially for agents that are doing decision making. They're not necessarily just taking actions, but deciding on if something's going to get approved or not. Another one that I want to call out, this is more on the financial industry kind of market. Again, I can't tell customer or the business, but it's an interesting one. You would never guess. Do you know the one thing that these companies still have a lot? Paper. So paper, money orders, fax, letters, all that. And it's not like you get a check. No, people write all over the check. They write the check and say, do 50% on my account X and my account Z. It's crazy, right? And these companies have basically paying like amazing, paying existing softwares that have excelled on doing only OCR to extract this data. But then what do you do with this data? There's so many steps between transferring that from digital to actually bits and bytes and then acting on it. And with agents, they're taking a few steps further. So now the agents are actually doing the whole OCR. They're using existing OCR models, also multi-model LLMs. They're doing analysis. They're pulling data from like the historical data that what happens, comparing, classifying, then passing it off to other groups of agents. They're going to basically prioritize those requests. They're going to queue them. They're going to assess the queue sets and then delegate, right? Like, all right, given these queue sets, I'm going to delegate to person A or person B or person C or department A, department B, department C. So very interesting use cases. The way that we look at these use cases and any use case out there is on these 4 quadrants where there's complexity and there's precision. So you can have high complexity, high precision. An example in here that we have seen is a company that wants us to help them with agents to fill IRS forms. So high complexity, high precision. You don't want to mess up the IRS. But the form was 62 pages long, what is insane. But fear not, it comes with an instruction manual. The manual has 720 pages. It's insane, yes. And then you have kind of like low complexity, low precision use cases where you say like, oh, I want to generate marketing like content, and like I don't care if it's 100% accurate. I want it to be more creative. I want to have more options. I'm ideating more than anything, right? Now, where you are in this cadence with your use case doesn't necessarily require that, oh, I only use more agents in low precision. No, you can have a lot of agents in high precision. So a use case that's high precision and high complexity is, for example, generating educational content. We're working with one of the biggest brands on education online, and what they want is basically fast track generating content for courses. And that's a very high complexity and high precision. Like they don't want to disseminate false information and they want to generate this, but this is creative. This is not traditional automation. You want agents to talk, to think, to be creative, to write about the different things. So again, it's a variety of use cases that you can get in here. And For all those use cases, we help them build it. And this is all open source, by the way. So on the open source, we got fairly well known by CrewAI Crews. And that's probably what you all know. And what allows you to do is build agents. In these agents, you have a few levers that you can control them on, like how many requests they make, how much time they have to do their work. You can add programmatic guardrails. There's a lot of different things that you can do with them. But in the end of the day, you're optimizing for more agency. You're optimizing for self-healing, for trying different things and all that. And then you have CrewAI Flows. How many of you have heard about CrewAI Flows? Very few, as I expect. So this is something that we need to start talking more about because this is super interesting. When you want to have like more fine precision use cases, you still can have code where you can have regular code, kind of like if this then that, and you can do regular LLM calls. But at any point in time, let's say that you want to have a pocket of agents in there, you can do it. So let's say that on the example that we just mentioned earlier, you say, hey, I want to pull Salesforce data here from somewhere. All right, I don't want an agent to do it. I want a regular code. Just go pull the code. Now I want to pull SAP data. All right, I just want a code. A code go there and pulls this data. Now I want agents to cross this data to see if this is my ICP, for example, or whatever you want to do with that. No worries, you can drop a crew in there. And then you have state and state management with this that you can do as well. But it's very interesting and serve for an entire subset of use cases that we're finding to be very helpful for most of the users out there. Now, we're going to talk about what we're going to build today. So if you want to build with us, this is the time where you start to take out your notebook. If you don't want to do it, that's okay. You can do it later. This code's going to be available. But meanwhile, just a quickie sanity check. Good afternoon. Better than the last time. All right. So we're going to build...
Interrupt for just a sec. There's a bunch of empty seats and a bunch of people standing. If you have an empty seat near you, put your hand up. And if you guys want to find a spot to sit where you can use your computer, this would be a good time. There's also overflow seating in one of the two rooms that are rebroadcasting this in the middle.
I'm doing on time, Jeff. I think I'm good. All right. All right, so let's talk about what we're going to build. And there's 3 cases that I want to build with you all today. They are pre-built, but we're going to go over the code and we're going to sit them together. And we're going to talk about everything that is happening on every single line. This is very much focused on open source, so everything that I'm showing you, there's no paywall. You can download the open source. You can use this. This is the way that I'm going to show you, and it's pretty cool. So the first use case is a very simple one. I want to easy our way into this. First one is preparing for meetings. It sounds lame, but it saves my life. I can tell you that. Whenever you have a fully booked calendar, there's going to be many times throughout my week, at least it's happening to me many times, where I notice, I have a meeting in 10 minutes with someone that I have no clue about. Someone else put this meeting in there. I don't know. And I have no information about this person, about this company, about what this is about, or anything like that. This is a use case that we use a lot internally in Crew, where these agents automatically research the person, the company, and even go one step beyond and try to find interesting angles like, how CrewAI fits within this meeting, within this person, within this company. So it's funny that I go from knowing nothing to jump into a call and say amazing news on the new facility that you folks got going on in Australia. That's incredible. And they're like, we're very excited about it. Yes, that helped. So we're going to build this real quick. I think this is going to be an interesting one. The second one that we're going to build is going to be a flow. It's a little more complex, but it's also more interesting. And the idea here is dynamically generating documentations for any project. Writing documentations suck, right? Everyone like to have good docs, but writing them is a lot of work. So this is a use case where we have a flow where there's a few pieces of regular code, like cloning the repo or saving the plan. But then you're going to have a group of 3 different groups of agents. They're going to map the entire project. They're going to plan what those docs should be. And then they're going to actually write the docs, and we're going to see the results of that. So that's going to be a very exciting one. And the third one, it takes us one extra step deep. And this is what we call conversational flows, where you can now talk within this flow. So it's a regular conversation. You're just sending message back and forth, single LLM calls, nothing fancy. But the moment that that chat realizes that it's not equipped to answer their message, then it kicks off a crew that is a data analysis crew that has access to a Databricks, and they're going to query this Databricks and extract the data in order to give us a proper answer. So this is going to be a very interesting one. And for this, because it's conversational, you want to make sure that they are fast. You want to make sure they're super fast. And that's where Groq comes in. Because with Groq, their main thing is they have the fastest inference speed out there. It's insane. They're going to show you some like plots in a second and you can do it by yourself. But we're going to be using Groq in another great partner of ours. We're going to be using Llama 3.3 from Meta. We love Meta. We're doing a few things together. Very excited to be partnering with them. And we're going to show how to use Meta 3.3 70B and how to build this. So those are the three things. Exciting? Not so much. Exciting? Yeah. All right. Now I like it. Yeah, there you go. Yeah, you are excited. So, all right. Let me jump into the code real quick, and I'm going to put this here. We're going to talk about those two use cases first. And then before we do the third one, I will call folks from Groq to basically walk us over some of their things on their side. Because if you want to build this now or later, they have a special gift. They're going to be able to bump your rate limits to the roof. So you can basically do a bunch of Groq. So that's going to be an interesting one. All right. So I'm going to show you the code. This code is available in a few different ways. You have the deep learning AI workshop that you can access where you can run everything online. And this is more safe in case like you don't have your environment set up or anything like that. So you can go in deep learning AI and there's going to be this CrewAI conferences workshop there. I'm going to be showing you the version that I have in my computer so that we can go over that. Because I did add some last minute modifications that, sorry about that. But you know me by now. And that's how I wrote. So we're going to show this, but it's roughly very similar. But it's just that we made it, I think, I have some crazy ideas last night and I was like, you know what? Let's go for it. So let me load up the code real quick and I'm going to close everything that we have. And don't worry, I'm going to zoom things in so it's not going to be this small. All right. Is this good? I think it's good enough. We have 3 lessons here. Let's talk about the first one, preparing for a meeting and what this looks like. Because we're doing this as a Jupyter notebook, it's slightly different than what you would do if it's something that you meant to ship it. If it's a project that you meant to ship it, when you have CrewAI, you have a command line interface, so a CLI, where you can basically do CrewAI create crew, and it creates an entire infrastructure, kind of like the boilerplate code for you. In here, we're doing a variation for that, so it's a Jupyter notebook, but I can show you the difference in a second. So one thing that you're going to notice is both using the CLI or using the Jupyter notebook, your agents and tasks are YAML files mostly. And I love this. It's easy to version, it's decoupled from the code, it's easy for people that are non-technical to update, and allows us to build a few features on the enterprise that makes the whole life easier. So if you go into agents, what you're going to see is every agent's going to have a role, a go, and a backstory. So those are going to be the main things that these agents will have. So in here, we can see that we have a researcher agent. They are excited. So you have a researcher agent. That's pretty cool. And you can see that I asked ChatGPT to write this for me, so it went a little overboard. I usually write shorter descriptions, but hey, this works. And then you also have an analyst agent. And here you see they also have a role, a go, and a backstory. Those are the main things. And the reason why we ask you to do that for agents, we have the time, so I think I'm going to just explain this. When you get LLMs to role play, they usually perform way better. And that's because the fact that they are AI models. So for people that have never done AI before, regular AI before APIs, I'm talking about classification models and such, it's always using what they call features in order to create a prediction. So for today, it could be, I want to predict if it's going to rain. So that's what I'm trying to predict. What are the features that I have? Well, I have decision, the temperature, the location. So these models, what you're doing is you're training them to find the correlation between the features and the output. And with LLMs, it's the same. So you're trying to find correlations of the features with what is going to be the next token. And the features are everything that was written up to this point. So whatever you read up to this point would be the equivalent of saying, oh, it's a hot day in the summer and you know it's not going to rain. So whatever you have reading up to this point in an LLM heavily influences what's going to be written next. And that's why role-playing usually gets LLMs to do better responses. And you can test this in ChatGPT. If you go in there and say, do a report in Tesla, and it's going to give you a report, and then you say the same thing, but you add, you are a FINRA approved analyst, and you're going to have a completely different report. So that's one way that you can test it out. So that's why agents in CrewAI, we make sure that they're impersonating something or a specific role. And then the tasks, in a similar way, they're also YAML files. And the only thing that they require is a description where you can describe what you want the agent to do when it's doing that task. And you can interpolate variables within it as well. And you also add an expected output. Many people early days on CrewAI, and CrewAI has been this like since day zero. Many people in CrewAI usually would, can I swear in here? Is it okay? All right. And people would give us shit. They would say like, hey, you know what? Why do I need to type an expected output if I already did the task description? Well, one, we're forcing you to do better prompting without you realizing. So without you realizing, we're forcing you to think about what exactly is that you want. When you think about the description, you might say, oh, go out and search for X, Y, and Z. And then for the expected output, you're forced to think, oh, I want a markdown file, and I want this to have only 3 paragraphs, and I want X, Y, and Z. So it's almost like a forcing function to get you to start to thinking about doing better prompts, and that's part of the reason why we do this. Now, some of the other reasons why we do this is that because now we can use the expected output to do evaluation on the actual output. So we can use LLM as a judge to say, hey, the actual output matches the criteria that you lined out on what you say that you expected. And that becomes a major metric as you're testing different models, as you're changing our prompts to make sure that you're seeing progress in the right direction. Pretty cool, right? You knew about it. It's pretty cool, right? Yes, damn, I found that so, yeah, sorry about that. So there you go, you have a few tasks, and all the tasks have the same thing. Descriptions, expected output. Now, let's look at the code. There's a few boilerplate things in here, so I'm going to skip that, like let's ignore warnings and all that. Let's install the dependencies, we can skip that. I even went to the trouble to make a nice animation, so hey, that's going to be cool. And after that, we're just loading environment variables. For this use case, if we go back into our slides real quick, one thing that you will notice is that these agents need to be able to research the web and scrape it. So we are using a tool, an integration called Serper. And they have a free account. You can go in there and create an account at serper.dev, and you create an account and you set up their environment key, and it just works. Just need to make sure that you have that key in your environment. Now, we do all the imports that we need. We like to try to keep things very lean. So in here, you can see that we're just importing the main things in CrewAI, that is agents, tasks, crew, and process. And then we're also importing a few tools, in this case, 2 tools. The Serper tool that I just mentioned, and the scraping website tool that basically allows the agents to scrape any web pages that they come across. So as they research the web and they find interesting information, they might decide to scrape those pages. They can do it now with those 2 tools. Now, I'm loading those 2 YAML files manually in here. This is the one difference when you're doing with the CLI. You don't need to worry about that, but we can ignore it here for now. And now we create our agents where we say like, hey, these agents are going to have their role, their go, and their backstory. And actually, I think we can even do it simpler where we can do config. I should look at the screen. There we go. You can do this. So it's loading out the config from the YAML file. You're saying that you want this to be verbose. And we're adding those two tools to this first research agent. So this agent now can use those two tools if it wants to. Same thing for the second agent, that is the analyst. It can actually now, it can't use tools. You can pay attention that there's no tools for the analyst agent, so that is not happening. Only the first agent's using it. And then we have the two tasks that I think we can also do the same thing. There we go. And in here, you're going to notice a few things. On CrewAI, the name Crew comes from this idea of multiple agents working together. In this case, because we're keeping very simple, you're noticing there is a map from one to one. There's one agent performing one task. Now, this doesn't need to be the case, right? Like in here, you can see that I'm saying the research task is going to be done by the researcher. The preparation task is going to be done by the analyst. I could not assign those tasks, and I could give them the manager, and the manager is going to delegate. The manager is going to get the first task and say like, all right, this task I'm going to delegate for the researcher. And the researcher is going to go off and do its work, and it's going to get it back with the result. And then the manager is going to look at it again and say, you know what? I don't like it. Do a better job. And then it goes back and redo it again. So there's a bunch of different levers, but I'm trying to keep it simple here, where it's just like one agent, one task, so that we can see this going. And by the way, I should be executing this real quick. So let me go ahead and boom, 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 boom. I do have the agent in the YAML. There's a few extra configurations though that you can do directly in here. So what we decided is to extract the tools components out of the YAML because that feels more of a technical choice. The YAML, what we're trying to do is make it super easy for like, let's say there's a PM, right? And he knows nothing about tech. He knows nothing about tools, but he's like, hey, I want to try change this agent and see like what happens. They can go in there and change that pretty quickly. So that's why we decouple them a little bit. But the idea is we're going to probably bring more and more into the YAML file eventually, especially like now that people are getting more used to that. So this is it. These are the tasks and everything is in here. And then you create a crew by basically grouping everything together. Like these are my agents, these are my tasks. And you can say like, I want them to do this work in a sequential manner. What it means task one, then task two. And this is where we could say, I want to do it in a hierarchical manner where like it's going to be a manager in the process. It's not our case. All right. So now I think we can run this and see what it will look like. So the first thing is it pops up to ask me, what is the meeting topic? Let me say that is an initial sales call with what would be an interesting industry? Finance. So with a big financial company. There we go. Enter the meeting participants. What would be a big company in finance? Citadel. Nice. So let's say that I'm meeting Jake at Citadel. And who's going to be Jake's boss? Joe. Joe. I like that. Joe at Citadel.com. Let's say that I'm meeting them both. All right, let's go back and fix this. Well, meeting brief, display. All right, so what it's missing is the declaration of the crew. So this is what got wrong. Context. All right. Tasks. Context. Drop this. Context. Drop this. There we go. Boom, boom. All right, so initial sales call with big financial industry. And it's going to be Jake at Citadel and Citadel.com. And we said Joe at Citadel.com. There we go. Boom. All right, so now these agents are working. And we can monitor some of the stuff that is going on here. So I'm going to zoom out real quick so that we can see it, right? So the first agent comes in, and we can see in here, they're like, all right, let me zoom in just a little bit. And drop this. There you go. So the first agent comes in, and like, there's the task. Your objective is to uncover insights, because I want to have a competitive advantage, analyze the topic, the participants came up with a strategy, and now that. So you can see that the agents decide to use a tool, like let's search the internet with Serper, let's see what we can find, and basically start searching what are the latest trends and developers in the financial industry in 2023. We forgot to say that's 2025. So there you go. It's going to start searching. Now it's going to read the website content. It's going to scrape it. Like, all right, I want to scrape one of these websites. And it's scraping at the Lloyd website talking about financial services. So basically, we're going to have a bunch of content in here that's scraped from their website. Then it decides to scrape another website, now Ring Central, saying like, all right, let me check what is the financial services trends and find more information about it. And we can scroll all the way back to see when we phase it off into a new agent. There we go. Now the new agent comes along. The first agent gives the final response. All right, like this is the report. This is the topic analysis. These are the participants. It found people in Citadel, Jason Curry and Joe Hudson. There you go. So basically came up with a lot of the strategic considerations, opportunity for alliance and everything. And then goes into the next agent that's actually going to use this information now. Keep in mind, this next agent can't search the internet, can't scrape web pages, so it's just an LLM, kind of like using all the context so far in order to come up with a strategy for that call. And if we scroll all the way back, here we have our final markdown. So one-page overview, we're talking about establishing a strategic partnership with Citadel, presenting tailored solutions. That's very interesting. Success criteria is securing the follow-up meeting. I agree, for initial sale calls, a follow-up is the way to go. Financial industry is adapting to investment strategies. So that I was focusing on technology and compliance. So probably I want to mention all the security features that we would have. The key participants have distinct priorities. So technology-driven risk and compliance. So there's 3 strategies in there that we can follow: aligning on the message, talking about data-driven, framing the opportunity, talking about Jake specifically and some of the things that he cares about, and talk about Joe specific and some of the things that he cares about. And then some talking points. I can talk about market dynamics, the shift in investment strategies, studies showing ROI on AI. So again, and even anticipated questions that I might get. How can these solutions adapt to our current infrastructure? Well, financial industries are very highly regulated industries. They probably want to do this in their own environment. They want to do this on-prem. So it's good that I can be actually ready for that. So again, very interesting use case, and even an execution plan, being agenda and everything. Now, in here, I went a little overboard, and I actually require these agents to write a lot. I could keep this one simpler. I could tailor it more for my company needs. I could give these agents a lot more context about I'm working on CrewAI. I'm talking about AI agents. These are our offerings. These are our things. I could give them access to transcripts of all of our existing calls and being able to perform RAG over that to find other financial institutions that we have met with and what actually drove good discussions with them. So there are so many different ways that we could expand here, but this is a very interesting use case. Any questions about this before we go into the next one? So I'm going to repeat the question. He said, like, on a RAG pipeline, usually it's something that kind of like operates individually, right? You have the whole chunking, embedding, persisting, and then you have the actual querying, probably reordering, re-ranking, depending on what you're doing, in order for you to get to the creme de la crop. How does that fit into this? And it's as a tool. So basically now you give the ability for these agents to perform the RAG as a tool that is going to call Pinecone, or it's going to call Chroma, and then it's going to return this information back. So we have a use case around that for support. And what we do is whenever we have phantom recording our meetings. So whenever a meeting finishes, we break it up, we embed it and push into a database. And then when we get a support ticket, we have agents that try to help to come up with an answer. And part of what they do is perform RAG search over all those calls to see if maybe there's a feature coming up, maybe there's a solution already in place, and that helps drive a response back with the tool. Yeah, it's a tool in this case. There's one here, and then you go for it.
Hi, my name is Rakesh. Quick question. Do you have any tools for evaluating the performance of these agents? Like, how do we know The agent was not hallucinating here.
Nice. So, did I kick it off? Yeah, so there is a few things. Is it on my side? All right. Oh, no, I think my computer is lapped. Sorry about that. Yeah, there you go. So you mentioned about how to evaluate, how we know that this is not hallucinating. So we're actually publishing a blog post with AWS next this month, probably. I won't say next week, but this month for sure. Very interesting about a use case that we did for cybersecurity that does that. We have one feature that we're not using here that is what we call programmatic guardrails, where you can literally either use other LLMs if you want to fact check them with that, or you can actually write actual code. So for a lot of use cases that uses kind of like information from the web, what we do is we add guardrails to check, for example, if all the links actually exists and there's content in their pages that map to what it's saying. So it's not coming up with kind of hallucinating a link that is a 404 or something, right? So sorry about that. My child just got sick, and I might be coming up on something right now. So I think that is that's basically it. So we have the programmatic guardrails is the way that we do it, but we also remember when I said that we use the expected output to measure the quality. So you can actually run. There's a command that you can run on the terminal that is CrewAI test. And that will execute your agent like 3 or 4 or 5 times. You can say how many times you want to execute. And it's basically going to get the output of each task and compare that with like what you actually got to say like, all right, is this matching, like, or is there information here that should not be here, is not complying with certain rules or something. On the enterprise, we have a nice UI for that I can show you very quickly. Just so that you see what that looks like. But we also support that on open source with the CLI. But on the metrics side, yeah, you have things like this where you can see, for example, what was the score or what was the hallucination of any single point in time when you're executing some of those crews. But again, you don't need, even though we offer free accounts, you don't need to create one if you don't want to. These also works on open source. It's just like a CLI called CrewAI test, and that's it. There was another one in there. All right, so you can, I'm going to repeat the question. He said, how the handoff between the agents work and how much control you can have over that. Actually, you have a lot of control. By default, one task pipeline the context into the next. But you can say, hey, I want to force 3 or 4 different tasks outputs as context into one. So that's the one thing that I was deleting was that I can basically say in this preparation task here, I want to say, hey, the context for this will actually be, and in here needs to be the research task. So now I know that the research, the output from research task is going to be passed as context into this one. And this allows you to do also tasks in parallel, where you can say, for example, well, if I really want to optimize this, I could have one agent researching a company, another agent researching each one of the individuals in the call, and then all that happens in parallel, and then I have a final report task that grabs context from all of that. And then what CrewAI does behind the scenes is automatically orchestrates everything. So runs everything in parallel, wait everything to finish, then pull all the different informations and then perform that final task. But there's a few other levers as well. Memory is another level of abstraction on top of that. So if you want to turn memory, you would turn memory on the crew level. So let me go up here when we set up our crew real quick. So here, if I'm not wrong, we have memory. Yeah, there you go. Memory, and it's a Boolean. So if you say memory true, what happens now by default is that these agents will have long-term memory, short-term memory, and entity memory. So entity memory is persisted across multiple executions, and they basically remember subjects, right? So if they learn, for example, what is Shack 15, that goes into there, and they always know that information now. The short-term memory is just like a buffer. It's like a RAM memory during the execution. On every execution, it gets resetted. But it's a way for you to share that information across all the agents being executed. And the long-term memory is more of a self-improvement kind of memory, where every time that they finish running, they kick off a background process that autonomously look at the results and what was the expected, and infer like, what could I have done better? And then that goes into a database that then they use as memory later to kind of like make sure that they're getting better over time. Nice.
I have a question here.
Go for it.
About the scraping tool, you mentioned that the research agent had access to it, but not the analyst.
Yep.
If that's replaced by, say, RAG, like proprietary data, who gets to access it? Which one?
You can choose. So you decide what agent gets what to and what access. So it's completely on your control. So you can say, oh, for the researcher agent, I want to give access to this database that I have, for example, so we can query it. For this one, I don't want to. Now, if you want a more granular level of control of scoping and permissioning, then we don't do that on open source, but we do that on enterprise. Because then like these companies require kind of like, oh, I want to have impersonation. So if my CEO is running the agent, it needs to have access to different things. But if my intern is running the agents, then it doesn't have access to different things. And then you want to have fingerprinting so you can trace back, all right? Like something went wrong. We want to like, what agent was at fault? We want to know what is the agent so you can like fingerprint and follow that along the process. But in here, for the kind of like of what agent got access to what tools, it's as simple as you just say like, hey, this is your tools, and that's it.
Thank you. Let me just rephrase this way. Why did you not give access to web scraping to your analyst?
Oh, this was just to illustrate an example where you have one agent with tools and one agent with not. Yeah, it's more like we can add more tools in here. And there's other scraping tools as well. Like this scraping tool is very simple. It's basically doing a crawl kind of like command. So that doesn't scrape many websites. We also have a Selenium scraper if you want to get more fancy that more mimics kind of like the whole thing. Or you can even use Playwright, and your agents can use Playwright to kind of like navigate the web. Or you can use partners of ours like BrowserBase. That is going to allow you to also launch your own kind of like browsers and do fancy stuff with that as well. Before we just go with questions, Jeff, how I'm doing on time? "45 minutes. All right, so this is going to be the last question because the two other cases are more complex. But it was that one, sorry. Go for it.
The question that I have is, how do you balance the number of calls that you're going to have in your system so you don't end up, when you're scaling and you don't want to have like 7 or 10 calls to an LLM, or when you're building that system, how do you balance or how do you think about it?
You can actually add constraints about that. So on the agent level, you can say, let me see if I'm going to remember that now. It is, damn, I wrote this code. Max execution time, it's 1, so you can limit on time. And then there's also max, let me do this, max iterations. There you go. So max iterations is how many LM calls it's going to do, and max execution time is how much time it gets to do it. The cool thing though is, let's say that you say like, hey, you only have 3 iterations. Like you have 3 LLM calls to crack this problem for me. What happens if it hits that 3, it doesn't break. We now force it to give an answer. It's like, hey, now you got to give an answer, whatever it might be. So it doesn't break. It kind of like finds a way around it. So you might have like in a situation like that, subpar results, but you won't have kind of like, oh, this broke kind of situation. No worries. And sorry, I know there was more questions. Sorry about that. It's just that I want to make sure that we cover the other use cases. But if we have time at the end, we do more Q&A. All right. So let's go into the next one. And that one's going to be a flow. That's the documentation creation flow. This is very interesting. If you want to try this one out live, another option is NVIDIA Blueprint. We have a simpler version that we have built with NVIDIA that you can try out that use NVIDIA NIMs. And in here, there's a description on how it works. It goes over everything. It's a very interesting one. That said, what I'm going to show you is more complex than what we did this. Basically, what happened is NVIDIA is a partner. We did an example. Now, NVIDIA customers are pinging us and say like, hey, you want to do this, but we want a better. So we built a better version, and that's what I'm showing you. That's the TLDR. So let me show you what that looks like. Keep in mind, this is a flow, so it's going to have regular code, and it's going to have crews on it as well. Again, a bunch of boilerplate code, setting up everything, installing, loading the environment variables, importing everything. A few things that you're going to see that we're importing now, they're new. CrewAI.flow. We are importing flow, listen, and start. And I'm going to see how you use those in a second. Because CrewAI flows, they are event-based automation system. What means that you have publishers and subscribers. So it's not a graph with predefined edges. It's like, hey, it meets an event. You might have other functions that are listening to that. Once that event's emitted, those functions then kick off. So we're going to see how that works in real life real quick. And let me make sure that I'm executing this along the way as well. Boom, boom, boom. All right. So the first thing that we do in here, oh, there you go. Did I execute everything right? Yes. 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 All right. So the first thing is, remember, this project, it's all about creating docs for an existing project. So I'm going to create a docs for CrewAI itself. So in here, we can just set up what is going to be our project URL. Again, we're doing this everything in a very hacky way, right? You could deploy this as an API on CrewAI Enterprise. You can integrate this with our systems and all that. But this is just like showcasing the art of possible. And then the first thing that we're going to do is we're going to create one crew that is going to be our application mapper. And if we go back in here, remember that we're going to clone the repo, and the first crew is going to map the project. So this crew will have, see it, one agent, just one agent, a principal engineer that has two tools. Directory read 2, so they can read directories, and a file read 2, so they can read files. And they have one task that is understanding the application. And all that is in a YAML file as well. We can go there in a second. But basically, one agent with one task, two tasks actually, they map the components, so understand the applications, and then map the components. One thing that I want to call out here that is very interesting, out of this mapping, what I want to get is I want to get structured data. So I don't want to get unstructured data. I don't want to have like text like we had with the meeting prep. So you can see here how we set up some pydantic models. So we set up, hey, here's a component look like. Here's what a relevant file object looks like. Here's like what a project report looks like. So a project report is going to have a string describing what this project's about, a project organization string describing a high-level organization of this project, a list of main components, and components here are name, descriptions, and files, a list of relevant files, and files here is going to have the path and the descriptions for these files, and then additional information that might be strings. So when these agents are running, what you're going to see is that the final output is going to be this structured object that is a component report. So it's going to be a Python instance of a class where we're going to be able to have all this information in there. It's going to be the files, it's going to be the components, it's going to be the tests, the whole thing is going to be mapped out. And that's pretty fun. Right? All right, that's pretty fun. All right, that's great. That's better. All right, so then we have the second one that is, let me see this one. This is a tool. This is a custom tool that we created in order for you to get more information about the components. So this is another cool thing that I think it's worth calling out is a lot of the tools that we have, we just talked about them, right? Scraping the internet, using Serper, access directories, all that's cool. But what if you have like an internal system that you need to connect this to? Like you have like your own amazing API and you need to connect this to that. How do you do it? You can create custom tools, and they're as simple as this. Usually it's less than 100 lines of code, and basically what they require is a name, a description, a schema, and one single function called _run, and you can do anything you want in that. As long as you're returning a string back for the model, you can do an API call, you can do gRPC, you can do a GraphQL call, you can connect direct to a database, whatever you want, that's fair game. As long as at the end, you're returning a string that's gonna be piped back into your model. So this is kind of like basically a component info tool that based on this maps all the components and returns every information about them. It seems to be more formatting the thing for us. Now, we're going to create our second crew. That is the plan crew. So now that we have that structured object, I want to have our crew that is basically going to plan what are the documents that we're going to create. This crew also will output structured data. This is the data that's going to output. It's a docs plan that's going to have a list of documents. Each list has a title, sections, prerequisites, associated entities, examples, goals, and the sections also have title, descriptions, and content. So you can see that we're planning out every single file that is going to have in here. And within those files, what are the individual sections that we're going to have? And now we put that crew together. This crew has two agents, a code explorer that can read directors and read files, and the actual planner that can also read directions and read files. And they're going to do two tasks, that is analyze the code base and create the documentation plan. And the final output, as you can see here, it's an output pydantic, output that object that we had at first. This one's more complex, I know. Are you folks following so far? Is that good? All right, that's good. Let's keep going then. Now let's do the final crew. I want to like a crew now that actually creates the docs for me. I want to write all this out. No problem. We add another custom tool in here. Actually, this is not a custom tool. This is a programmatic guardrail that we're talking about. So one thing that I want in my docs is I love mermaid diagrams. I think they're so pretty, right? Like they see how the things connect and everything. But the problem is AIs a lot of times get those wrong. They write it out and it's not valid. So it plots nothing. So I decided to add a guardrail that will force an agent to only complete a task after this function returns true. And this function is validating mermaid syntax, making sure that the syntax is valid. If the syntax is not valid, the agent will basically not be it's not done. Figure it out, try again, up to the point that this is valid. So this is very cool, guarantees that we get the mermaid diagrams that we want out of that. I don't think I validate everything, but I validate a good bunch of of the syntax. And then this crew is basically two agents, overview writer that now can basically read directors, read files, and look, this tool is different. It's a website search tool into Mermaid. Website search tool, instead of scraping, is basically a RAG tool. So that means that in runtime, it's going to download the code, download the content of that page, embed it, put into a Chroma DB locally, and these agents now are going to be able to perform query over that in runtime. So that's pretty cool. And then the documentation reviewer can check a few existing docs and also kind of read the files as well. And then you have two tasks, draft documentation and then another one for review and QA. And in here you can see the guardrail in there. So basically check the remade syntax, and I added a max retries of 5 times. So try to check the syntax for 5 times. If you're not able to, then just move along. All right, so let me see if I don't think I executed everything along the way, my bad. So let me go back up to the top. The Chroma DB is for indexing in real time the Mermaid docs and allowing the agents to perform RAG over that. So we're not getting the whole docs and just pushing them into the LLM, but the agents can see oh, I want to draw this kind of diagram. Let me see what I can find in there. All right, so now I'm executing everything. Let me zoom out, make sure that nothing breaks as we run. There we go. You see the chroma in there? Let me zoom out a little bit. Sorry. There we go. So if you see the chroma in there, it already downloaded the web page, already indexes, like that's already ready to query. Go for it. You can use, yeah, we can use more than the chroma, and you can also change everything. By default, it's using OpenAI embeddings, but you can change all that. So if you go into our docs, it kind of like have a very granular level of kind of like, let me see if I can find here, reg. Where is the website? Website, search, tool. Yes, this one. So I think in here it goes over, yeah, there you go. You can specify what is the model that you want to use, what is the temperature. You can change a lot. You can change what is the embedder, and you can also change what is the actual DB, even though it doesn't mention in here. There's extra functions that you can do. So you can get it very custom, but then this becomes like a little ugly for demos. So I'm just rolling up with OpenAI. Go there. For this one, I would need to double check. I think it would be most static ones. You could build one for dynamics one if you want to. Again, the cool thing about tools is that they're regular code. So anything that you can put into a function, you can make that a function into a tool and it should just work. Now, I think we can plot. The cool thing is you can plot flows because they have this idea of like doing one thing and then the other. You can plot them out. So all you gotta do is do CrewAI flow plot. And I actually just did it in here. So let me actually show you what that looks like. CrewAI code, oh, not code, sorry, open. And then we can go in lesson 2 and we can do into flow. So here's what our flow looks like if you just plot it right away. It shows you like clone the repo, then mapping the structure, then planning the docs, then saves the plan and create the docs. And I didn't show you the flow. Sorry, I skipped through that real quick. So let me go up here real quick and show you because that's the fun part. This is what flows work in CrewAI. So all you gotta do is you make sure that your class inherits from the flow class, and you, oh, more zoom. Let's do more zoom. All right. So you can create a class, and all you gotta do is make sure that it inherits from the flow class. You can add state to it as well as we are doing in here. So you can see that in the state, we have the project URL, we have the repo path, we have the docs, we have the report. So as these crews do their work, they push their outputs into the state so that you can reuse them across the different functions of the flow. And the part that I love the flows is that it's so that simple. Like you want to define what is going to be the first function of your flow. You just annotate it with start, and that's it. That's the first function of workflow. That's the first thing that's going to be executed. Now, after cloning the repo, what is going to happen next? Well, all you got to do is listen in the name of the previous function or the function that you want to listen for. So as soon as clone is done, and that's regular code, you're going to start mapping the project structure. And mapping the project structure here is that crew that we created before. We can see that we're kicking off that crew right in here. Then listening to map structure, we have the planning that is going to kick off the same thing, the planning docs. After that, you can see that we have two functions that are listening to planning docs. One is to save the plan, and the other is to create the docs. When you do this, automatically those functions are executed asynchronously in parallel. And that's why when we plot them out in here, or in here, they show up as parallel executions because both of those functions are actually listening to plan docs. So that's kind of like how you can get things to work in here. Yes, you can do ORs, you can do ends, you can do routers. There's a lot that you can do, yeah. And I think the next example is a router. Actually, I might need to rush through that, but we're gonna get there. All right. So now that we plotted it, let's run it. Let's see what happens. So, boom. So the first thing that we see is cloning the repository, clone CrewAI. Repository already existed, that's okay. So remove the existing directory and now cloning it again. We want to make sure that we start from a clean slate. And then after this, the log's going to take a while because I basically hide it up. But there you go. Mapping the project structure is starting. And we can see some of the crews now kicking off. So listening to files directories and reading files contents. There we go. Yeah, I think like I don't think I can scroll in this. There we go. Yeah, so we can see here I hidden the logs a little bit, so it's not too much. But you can see like reading files contents, listing files directories. So you can see as these agents are progressing it, they're trying to map the structure and go over it. While they do it, I'm gonna make sure that I have in here. I'm gonna drop everything that we have in here. So there's no previous docs in that folder. It's just like docs will go here and we can see what they will look like once that is finished running. It should be pretty fast. It might take a few minutes. So while that runs, any questions? All right, there's one there, one here. Go for it. Yes, you can do routers and you also can do ORs and you can also combine the both if you want to. The next example is going to have a router where it's if something do that, if something do the other. What do you mean by that? Oh yeah, you can do that as well using routers for sure. We use that for lead enrichment. So we're like, hey, put the information of like, let's say that you sign up for CrewAI. We put the information about you. Then we have a crew that's going to score you as like, is it a good like potential customer? If it's over 95, then goes into another crew that writes an email right away and just sends it. If it's under, then it goes into something else. So there's something else there. I think there's one up here. Yeah, that's one way. I think in the terms of customer value, they help with the same thing. The architectures are widely different. So what the question was, by the way, sorry, is this fair to compare LangGraph with CrewAI flows? And from a user perspective, yes, absolutely. From a technical perspective, not as much. Like the structures are vastly different. One is very graph-based and has the whole idea of edges and all that. While we have on the other one is what we have in flows is more kind of like a sub and pub base. And what it helps us with once that we go into enterprise is we can scale these different functions at different rates. So because all those things are kind of like very much apart, we can say like, all right, this function gets more events and more listeners than others. So let's maybe scale that up server wise compared to everything else. So we can do a little bit of more fancy things on the back end because of that approach. And then a final question before we bring to talk about Groq, or two final questions. You raise the hand first, so yeah, go for it. Well, the way that I deploy it, that I can tell you, is on the enterprise. That's what I use it for. So in here, I deploy integrating with GitHub, where basically I can come in here, I can select a repository. So if I have any flow in here, and I might have one, there you go. I can select this flow, select the branch, add environment variables that I already have pre-registered, and I can click just deploy, and that deploys right away, and this becomes an API for me now, and I can connect with many things. Now, you can also deploy on your own, but then all that layer needs to be figured out. Yeah. So the final question before we go into Groq.
I was having one.
Oh, there you go.
Yeah. So I have two questions basically. Partly, one thing is that are the tool class customizable? Can we create our own tool on top of the tool?
Yes.
Secondly, we see the logs. Logs are very verbose, right? Do we have a control over the logs over here? And what about debugging? What about something fails over there? How quickly or how fast is it to look at the logs over there?
Yes. So what I would say is logs in here are hard to grasp, right? That's kind of like hard for you to kind of like go over all of that. That said, we do have an observability layer on enterprise. I don't think that's enabled yet, but I can show you photos. I have it. Yeah, I do have them. So you can see here on the left where you see like the steps that happen, the LLM calls, the tool usage, and you can see the actual prompts and the inner prompts and everything that happen. And I think there's even more stuff in there that you can look at. There's some indentation. So we have some layer of observability. And again, there is free accounts, so you can use this for free. And then in there, we also allow you to route those logs into like major systems. So you can push these into Datadog, you can push these into Splunk, you can push these into Loki and all those different things. But on the open source, what you have is the stream of logs. And then if you want to, you can pipe that somewhere else, but then there's extra coding there.
Makes sense. Thank you.
No worries. And by the way, it wrote some docs, so I'm going to show this real quick. So you can see initial system architecture doc that goes over what are the module architecture expert, the core components of CrewAI, agents, tasks, the process, the memory management, talking about short-term memory, long-term memory, entity memory, talking about tool integration, event drive, config management, execution flow. So very interesting, talking about the interactions, talking about some of the code, talking about some of the tasks. You can see that it's quite a lengthy doc. And then again, it's still popping up more docs in there. We have like things like the developer guidance. Let's see what that looks like real quick. Yeah, so there's an introduction with the purpose, the project, high-level features, conclusion, key features. Again, it's just writing out those docs now in the background. Now, before we talk about our final project, and our final project's going to be conversational, so it needs to be fast. We're going to be using Groq with Llama 3.3 now for that. I would love to basically talk about what is Groq. And before that, who know what Groq is? That's an amazing show of hands, dude. All right, come on, fill them in.
That's it. All right, thank you for that, João. And here to do the show of hands of how many of you are familiar with Groq, which is fantastic, and that's exciting, Jerry. Raise your hand if you're already building with Groq. All right, quite a few as well. So my name's Graham Steele. I'm a senior product marketing manager at Groq, and we're going to give you a brief introduction to Groq and show you how you can use Groq to take those crews or those agents that we were just learning about and turbocharge them. So now you can do a whole new class of things and truly have them conversational. Now, for those of you guys who aren't familiar with Groq, at Groq, we specialize in providing record-setting fast AI inference across text, audio, and vision modalities. And we do that through offering them through our cloud, Groq Cloud, which has a variety of models serving those modalities, and we offer them all at a very competitive price. Meaning that you're not going to break the bank when you take that application and it starts to scale and you have more and more user adoption growing. And just to set the record straight, because I get asked these questions at every single event I go to, we don't make any of the models that we run in our cloud, at least not yet, and there's no such thing as a Groq LLM. Rather, we primarily use openly available and open source models. Time and time again, there's a reason why open always wins. Look at servers. Nearly every single data center and a server inside it runs Linux. And there's a reason behind that. But more importantly, we want to keep the destiny in AI in the hands of all of you guys here. We don't want it just being controlled by the elite few. Rather, we want the masses to control the destiny of AI. And our secret sauce behind our performance is the LPU, or the language processing unit. We don't have any GPUs powering our cloud. It's all the LPU which we created. So what exactly is the LPU? Well, it's a chip we specifically designed and optimized for the workload characteristics of AI inference. You can think about it back in the 90s when the GPU emerged. It emerged to offload graphics-intensive tasks from the CPU because CPUs were just too slow for gaming and rendering. Similarly, we offload the inference-intensive tasks from this GPU. And to be clear, GPUs are great for training, but they're really poor when it comes to fast AI inference. And that's where Groq comes in. And now this is the point normally in the talk where I show a demo to make it real for you guys, but you're about to do that and test it out for yourselves with the next section building on top of Groq. So I'm going to show you guys a chart. And what this is showing is the performance for Llama 3.3 70 billion. And what you'll see, Groq all the way on the left-hand side there, significantly faster than everybody else. But there's an important footnote to this chart, and that's underneath. This is based on running multiple simultaneous 1K prompts. And this is all tested by an independent third-party artificial analysis. And while a lot of providers like to show flashy performance with just a single call, that's not related to real-world performance or production workloads, especially when it comes to things like agentic AI. You're going to have multiple simultaneous prompts running to get that information back and have numerous crews all interacting to get the answer you want. And so when it comes to actual production performance, that's why you want to use Groq. And so you can think of it as, typically with other providers, your crews are driving a sedan. Yeah, you're going to get there, but it's not going to be fast, and it's probably not going to be in the time that you need to get the job done. So when you give your crews access to Groq, it's like you're giving them a Formula One car. Now they'll reach their destination instantly. And because of that performance and speed we provide, we've grown to over 1 million developers on Groq Cloud in launching in just 1 year. Literally last February, we went from no users on our cloud when we launched it to today over 1 million users on there, showing the market's need, appetite, and hunger for fast AI inference so you can unleash the true potential of these largely capable models. So now that we've gotten the brief introduction in Groq, let's get into the things you need for this next section to get up and building. So if you guys haven't already signed up for Groq, all you need to do is go to console.groq.com or scan that QR code, and it's completely free to sign up and get started. And to be clear, we will always have a free tier. It's not like it expires in 30 days. It's just a matter of rate limits. Just make sure when you log in and sign up, you don't use a Yahoo, Outlook, or Hotmail account. We ban those domains. There's a lot of abuse early on. And so you use an email domain from not those, or you can log in with your Google account or your GitHub account. And once you log in, we have access to a variety of models you guys can use. All of our endpoints are OpenAI endpoint compatible, meaning it's 3 lines of code to switch over your existing applications, change out the base URL, add in your Groq API key, and select the model you want, and you're up and running. It's also native integrations for providers like Crew, so it's easy to start working with them. And then we have stuff like tool use, function calling, JSON mode, streaming, and much more features to give you all the things you need to truly build fast. But once you get your account created, we want to give you guys increased rate limits to help really allow your crews shine in this next section. So this QR code is a form. All you need to do is fill that out. But importantly, you have to add in your organization ID in the Groq Cloud Console. You can find that by clicking on your face or your name in the top right-hand corner, then go into settings and add that in. And that just lets us know whose account to give the increase to. And we have folks working behind the scenes right now that are adding those increased rate limits in real time. So as soon as you submit the form, you'll be able to go ahead and get that. So let's dive into that section, but I did want to leave this with you guys. The reason why we provide this fast inference is we want to enable the entire ecosystem to build fast. And we're constantly impressed with everything you guys build. So if you build something cool powered by Groq, give us a shout out on social and we'll highlight your work. So I'll hand it back over to João so we can dive into the next section.
All right, talk about fast. And it should tell you something that I have Groq stickers in here as well. I do like it, and they can probably hook you up with some as well if you want to. So yeah, go bug them. Let me see if I can get everything up and running again. No time. We're in crunch time here, but hey, we got this. All right, let's talk about the final crew. It's a conversational crew. The good thing is it's built on top of everything that we have seen up to this point. So it should be fast for us to catch up on everything that is happening. First, it starts with a bunch of boilerplate code, importing things, load environment variables. Pay attention that we are importing more stuff now. We are now importing listening, start, persist, and router. So we're going to talk about that router there, and we're going to talk about persisting state as well. So that's going to be very interesting. We're going to be using Llama 3.3. One thing that you might notice is a bunch of these models, they're fine-tuned on very specific or trained in very specific prompt formats. And using those formats can very much boost the improvement. So what we did is you can set up those templates that you used to be training those models to now be used on the inference side for these agents. So if you go into Llama's website, you're going to see that this is the actual pattern that they train those models in. So if you use that same pattern, you do get better results. So we can automatically use that in Crew. That's no problem. When you're creating your agents, all you got to do is pass a system template, a prompt template, a response template, and it's going to use those same templates right there for you. In this case, one tool that we're using is a Databricks query tool. And you can see in here, and we can set up a catalog, a schema, a warehouse ID. Let me see if I can show you what I have in that Databricks real quick. Well, while that loads, if I can get it to load super fast, let's see. Boom. There we go. What I loaded in there is basically a series of Netflix catalog. So there's a bunch of information about Netflix overall data. So kind of like what they have, what are the movies that they have. Let me see if I can kick this off. There we go. So it's basically a bunch of like information around the movies, the launch date, the movies that are recommended based on that, what is the genre of the movie, what are the people in there. So it's an open data set that you can get from Kaggle if you want to. And here you can see the title, the genre, the subgenre, the year, everything is in there. So I decided to just give my agent access to that like database now. So you have the entire table, it's up to them, they can query that. And then I created two agents, an information agent, an information movie agent, and a movie recommendation agent. I gave them a couple tasks to search movies and recommend movies if they want to. And now I'm going to go ahead and create a flow. The flow in here, it has a state. It has, remember that this is going to be a conversational flow, so you're going to be sending a message to this. So it has a message that is going to persist on the stage. It has what we call a query result. I don't think we're using this anymore. This is one of the changes that I did last night. But basically, what they're doing is holding up the history conversation as part of the state of this flow. So now, the start function is basically setting up for us to use Groq Llama 3.3. And they mentioned that it was 3 lines. With CrewAI, is 1 line. That's all you got to do. Now you're using Groq Llama 3.3, and you can use any other vendors that way as well. You can see that the second function is a router, where you can say, hey, and it's not on the router, but it's also using OR. So the listen for user function, for user input, is going to be executed after start conversation, after answering the user, or after executing the crew. So after any of those 3 functions finish it, it's going to execute this. And the thing that it's a router for is because it can send either to end the execution or sends the message like is received. Am I at time? 3 minutes? All right, we got this. Brace up. Let's do it. So the first function is just doing one single LLM call. Check if you need more details about the movies before you answer this. If you do, if you don't, return with answer. If you do, return with run crew. So if you do can answer it, it's going to basically do one ad hoc LLM call to get you the answer and give your answer back. If it needs more information, now it's going to kick off our entire crew that's going to search Databricks in order to get more information. So let's run all this real quick so that we can get to the fun part and see some of this execution happening in runtime. And also there's a few things while that runs. You're going to see that I annotated the entire flow with this persist annotation that automatically create a persistence layer that every function in this flow gets persisted into a database. So at any point in time, you can, let's say, restart this flow with the same ID, and it's going to reload out the state and pick up the conversation for where it started. So it's going to have all the message history, everything's going to be in there. All right, so there you go. It's running and it's asking for a message. I'm going to say, hi. For that, it should not use a crew, so you can see that it was super fast. Nice to meet you. I can say, how are you doing today? And check out how fast this is. I'm doing well, thanks for asking. I'm a large language model, yada, yada, yada. And now I can make a question about like the actual, an actual movie. I can say, what is the oldest movie in the Netflix catalog according to Databricks? Data. Boom. And now it kick off the agents. Like, all right, we're gonna need agents to figure this out. So you can see that it's now writing queries. And there it goes, getting recommendations, the release title, getting all the data. It's so fast it's hard to keep up with the logs. Groq, please make it a little slower, just a little bit slower. Yeah, it's hard to keep up with logs because you can see it already did a query, it already returned the information, already found out what is the movie, and now it's probably done by now. Yeah, it's already done by now. So here we go, like based on inquiry about this movie, here's a few others that are interested for you, and basically gives like a bunch of recommendations based off that. So this was me kind of like updating this last minute, but here you can see a combination of everything that we learned in these 9 minutes, where we're using crews, where we're using flows, where we're using conditionals, where we're using different LLMs, we're using validations, everything to create automations that were not possible before. That is very exciting. If you want to know more, go into CrewAI.com. There's a bunch of information in there. If you want to get access to Enterprise, there's a free account. All you got to do is do app.crewai.com, and you're going to be able to create an account in there. And thank you so much for having me. This was a great time.